Let's do a 2D kinematics problem. It says, a hiker wants to cool off by jumping into the lake below. She runs from rest on a horizontal cliff and jumps into the water below. To avoid the ledge below, she must land 1.75 meters from the edge of the cliff. The cliff is 9 meters tall. If her running acceleration is 0.08 meters per second squared and she starts from rest, how far from the edge of the cliff must she start running? So the question is asking us, how far should she start running so that when she gets here and jumps into the water, she can avoid this ledge right here, okay? Now, let's try to figure out this change in x, okay? What do we know about this portion of the problem where she's running from where she starts to the edge of the cliff? We know that her initial velocity is 0, okay? We know that her acceleration is 0.08 meters per second squared, and that's pretty much all we know just for this portion, okay? And we're supposed to figure out the change in x. Now, we don't have 3 kinematics variables to solve for change in x. Whenever we're given 3 kinematics variables, we're able to solve for the other 2, but since we only have 2 here, we are not really able to do anything. So, we're given a lot of information about the height of the cliff, how far she has to land. So, let's try to do something with that. Now, we can organize a lot of our information in this table right here, okay? So, change in x, initial x velocity, final x velocity, acceleration in the x direction, and time, change in y, initial y velocity, final y velocity, acceleration in the y direction, and time. Notice I don't have any subscripts for time, and that's because they're the same for both. Okay. Now, change in x from where she is at the edge of the cliff all the way to when she lands in the water has to be 1.75, okay? So that's given. Then initial x velocity, we don't know. Final x velocity, we don't really care about. Acceleration in the x direction is going to be 0, and time, we don't know. Change in y here is going to be -9 because this is 9 meters tall. Initial y velocity is going to be 0 because right here, she's accelerating in the x direction, but she's not really gained any velocity in the y direction, okay? Then here, nothing, and then -9.8, okay? Now, since we have 3 variables right here, we can solve for time and use that time here so that we can solve for initial x velocity, okay? Let's do change in y equals VOT plus 1/2 AT squared, okay? So change in y equals -9 equals initial y velocity, which is this right here, is 0. So this term cancels out. 1/2 acceleration -9.8 and t squared. That gives us time as 1.355 seconds. Okay, now we can use that to solve for initial x velocity. Okay, we can use the same formula. So change in x equals initial x velocity t plus 1/2 AT squared. Okay, change in x 1.75. We're solving for initial velocity, and time is 1.355 plus 1/2. Now acceleration is 0. So whatever I'm going to write here is just going to be 0, okay? Because acceleration is going to be 0. So initial velocity is basically 1.75 divided by this, which is 1.2912. Okay. Now that we know what this is, we can solve for change in x, okay, which would be this distance right here. And how do we do that? Because we know that the final velocity, if we're looking at just this scenario, our final velocity for here is going to be the initial velocity here. That's because when we did this, we were just looking at this is the initial position, and then her getting into the water as the final position. But the same initial position right here that we use over here would be the final position for this problem right here. So this is basically two problems that we're doing, okay? I hope that makes sense. So final velocity is going to be 1.2912, okay? Now we're solving for change in x. We're given 3 kinematics variables. So let's use this formula, okay? Zero squared is just 0 plus 2 acceleration times change in x, okay? And this gives us change in x as 10.42 meters. And this is your final answer. Ooh. This is your final answer.